Thanks for the opportunity to present to you today on what's currently happening in the UV space, particularly coil cleaning, as well as air and air disinfection using UVGI. There's quite a bit going on in the marketplace. First things first, when we're talking about 254 UVC, we're talking about wavelengths below the visible spectrum. So we see between 400 and 700 nanometer light, ranging from the sort of deep purple to dark red. UVC is invisible, and the only reason why we normally see UVC lamps operating is that some of those lamps are operating up in the visible blue light spectrum. And the UVC wavelength that we're really particularly interested in is 254 nanometers. There's another UVV part of the spectrum, which is even higher power, 187 nanometers, which I'll touch on. But the dominant wavelength we're talking about is 254 nanometers in wavelength. Just as a general comment, UV technology is really widespread in the water industry. It's just about universal. If you buy a bottle of water, it's more than likely been irradiated by UVC, and that's been used to kill any microbes in that water. With surface and air cleaning applications, it's rarer but becoming more common. I just want to give a quick overview of the various air cleaning technologies currently out there, or how we classify the different air cleaning technologies. And the first one, of course, is mechanical filtration. There's 4 boxes, purple boxes along the top here. Mechanical filtration, which is, the typical physical filtration that we're used to. UV is in its own category. It's described as a targeted reaction. It actually impacts on the molecules within a pathogen or organism and denatures the DNA so that it can't reproduce. That's the mode of action. There's also a really broad range in the marketplace now of different electric air cleaning technologies, photocatalytic oxidation, ionization, plasma technologies, and then you've got your not contained reactions, which is basically fogging type technologies, which you're seeing more in public spaces, and I'll go into a bit more of these technologies towards the end of the presentation. But just as a quick overview, and perhaps to differentiate mechanical and UV from some of the other technologies, because UV has been around for a very long time, and in fact has been promoted. That's been promoted by NIOSH in the US. Which is the equivalent of our Safe Work Australia for the hospital sector, upper room UV GI, and they put out a publication recommending that after a problem within their hospitals with disease spread. ASHRAE is also the equivalent of the Australia's AIRA's, the HVAC sector association in the US is ASHRAE, and they've been very big on providing obviously mechanical filtration guidance, but also guidance on UV radiation, and they've put out a number of publications around that. They've been pretty quiet on electric air cleaners because of the complexity of evaluating them, and there's so many different types. But they are very anti-ozone in the breathing space of people, and there's been a problem with ozone generators being sold in the general market. Our own Lydia Morawska has been quite public on promoting filtration of air and UVGI for cleaning air. Pretty silent on electric air cleaning technologies, and again silent on open fogging. The UK National Health Service recently put out a publication on UV in the health sector, the UK health sector, essentially promoting it, endorsing it and promoting it. And it's a 2023 publication, worth a look. All the references are listed here below. Shelley Miller works for the White House Task Force. She's a leading air quality expert, academic in the US, and she's also, as part of the White House Task Force, has been very strong on filtration of air and UV treatment of air. Certainly a lot of question marks around different air cleaning technologies. Some of them may emerge as winners in the current very, very busy market in that space. But Some new standards are coming through to help evaluate these air cleaning technologies, and particularly looking at how effective they are and what sort of byproducts they produce. You've also got some technologies coming through where they are putting reactive species in the breathing zone of people in public spaces, and I'll touch on that a bit later. But it's a very interesting space. There's also work going on through Standards Australia on the adoption of some of the ISO standards for UV devices. And there's three particular standards we've recommended for adoption through the ME80 filtration committee, which is an Australian standards committee. The first one's just a safety devices, safety information really for UVC devices, so permissible exposures, what sort of PPE you need around UV lamps, and how possibly to dispose of UV lamps. The second standard looks at the measurement of the output of UVC lamps, because there's very, very many different ways you can measure output of a lamp, and you really have to standardize temperature and distance from the lamp. And it does that so you can compare apples with apples in terms of lamp intensity. And the third standard, it looks at what sort of UV dose required to activate microorganisms within a duct. And I think they'll be very useful standards if adopted, or when adopted in Australia. Just wanted to provide a bit of a background on different UVC lamp suppliers and systems. There are actually not much differences in the actual technology used. They're all low pressure mercury lamps, and these all surface and air disinfection lamps supplied to the Australian market. They're hot cathode filament lamps. Around 30 to 40% of the input power is converted to UV, and about 85% of the emissions, there's some in the blue light area that's visible, but 85% of the emissions are in the 254 range. There's a bunch of different glasses that can be used, and I won't go into this in any detail, but basically there's a soft glass which is pretty lousy because it actually stops UV transmission pretty quickly. It gets affected by the UV. What's used commonly is pure fused quartz, and there's two different types. One allows a little bit of the 185 nanometer light to go through, and it's very effective for odor control. And it's used in waste facilities and for hemp growers, particularly in the US, which has got a very active hemp market now, legal hemp market. But most of the lamps we sell and distribute for surface and air disinfection are using a 219 quartz, which limits the generation of the 185 nanometer light spectrum, and which means that you're not getting any ozone generated. 185 does generate ozone. Bit of a all the manufacturers essentially are playing in this space. Now, that there is a huge difference in lamp life, and this is a Philips publication that just set out the different things that affect lamp life: the switching, the type of current going through there, the electrogeometry, ambient temperature, circuitry. And so that's a key point of difference with some of the suppliers in the Australian market in terms of lamp life. But essentially, it's the rate of loss of coating on the electrode that determines the actual lamp life, and that's the actual mechanism by which these lamps decay over time, and some decay very, very quickly in under 6 months, and some can go over 2 years, still giving significant UVC off. So that's something to look out for. There is a relationship between lamp intensity and lamp life. So a lot of lamps that burn very hot and very early, and they promote the intensity of the lamp, they actually have quite a short life. They fall off a bit of a cliff after about 12 months, and you don't get much UVC being generated after a 12-month period. Primary reference sources for understanding surface and air disinfection. We rely very heavily on a book called The Ultraviolet Germicidal Irradiation Handbook which is written by Vladislav Kowalski, and he's pictured here in front of a banner of Sanovox. He joined Sanovox a couple of years ago. So he's researched UVGI for many years, and the book is really a compendium of research undertaken over about a 70-year period. Actually, some of these studies are very old, looking at the impact of UVGI or 254 UVC on these various species, and this is just the Aspergillus species, but there's tables and tables of this. So there's a huge amount of data behind UVC 254 and how it impacts on pathogens and microorganisms. So why use UV on coils, for example? And this is an example of surface cleaning, and this is a publication by done in 2017 in looking at the impact of UV on coils. This is in the air handlers, and there's basically a very significant reduction in pressure drop, up to 14% after UVGI has been installed. There's improvement in face velocity on the air handlers between 11 and 14% after UV is installed. And there's also a reduction in the amount of chilled water requirement demand. So there's some real energy saving implications. This study was done in Singapore. So this is for a tropical country where you have much higher humidities, but very impressive set of results there for tropical areas. There's also a large amount of literature. There's some older studies. There's a 2003 study showing a 99% reduction in microbial contamination on exposed surfaces within an office environment where UVGI was installed. Airborne bacteria was also reduced, and it did. This looked at survey results and very significant improvement in worker well-being. Another publication, this is a 2020 recent publication, which summarised studies on why disinfection of devices may be beneficial, and Lydia Morauskas is lead author on this and strongly endorsed UVC technology. So our primary reference sources, in addition to Kowalski, we have the ASHRAE publications of their handbook. There's 2 chapters. They're quite lengthy, but in terms of coil cleaning, they recommend irradiation of 50 to 100 microwatts per centimetre squared as the recommended dose for coil cleaning. And when we do use our sizing software for installing coils, and this is an example of a coil of 1200 by 2500 in dimensions, millimeters dimensions, and it's got 2 lamps in front of it. We aim for a minimum of 250 microwatts for those types of installations, which is well in excess of those levels recommended by ASHRAE and Kowalski. Just looking at current tendering practices, though, what we're seeing is much higher doses being recommended on coils, and this is a result of DA15, an ASHRAE publication, which has recommended 1225 microwatts per centimetre squared on the face, and that's sort of an end-of-life intensity of 750 microwatts per centimetre squared, which are really very high levels in our consideration. That's 753 times what we recommend for cleaning coil. And if we have a look at DA15 and the wording of DA15, they have recommended the ASHRAE levels of 50 to 100 microwatts per centimetre squared straight out of the ASHRAE handbook, but they also they've also picked up a reference of the 1225 to 750 microwatts at end of life, which is straight out of a sterile air publication from which is available on Amazon. And if you go into the Sterile Air publication, then there's actually no real defined reason why they recommend those levels. We think those levels are very, very high. And these levels are being, adopted by a wide range of consultancies. Those numbers are becoming very widespread, and we've made representations to ERA that perhaps they may wish to revise that publication sooner rather than later. The implications for energy use, of course, if you're running it at, let's just use the 750 microwatts versus the 250 microwatts that we recommend, the cost of running that in a very small air handler is sort of 3 times the amount of consumption. So the question being asked here is, well, why would you want to do that? Now, you may want to have higher UV intensity on very, very thick coils. So this is a diagram showing UV penetration in coil, and when you're getting above 350 millimeters in thickness, then you're starting to have to increase the power significantly. If you're irradiating one face, our solution is to actually install lamps on both sides of the coil at 250 microwatts, and that meets all requirements for any size coil. The other reason why you may wish to go for higher intensities is to essentially kill 2 birds with 1 stone and try to achieve some degree of air cleaning. And ASHRAE's given some guidance around this in their on their website as a result of COVID. And this is in the context of trying to kill a significant amount of COVID. They recommend 1,500 microwatts per second per centimetre squared, which is actually 1,500 microjoules per centimetre. That's a dose. And if you can get that sort of dose on the air moving through a coil, then you will achieve a degree of disinfection, an unspecified degree of disinfection of COVID-19. And there's some conditions for that. You can't have the air moving faster than 2.5 meters a second, otherwise you just won't get the exposure time. And you need a minimum radiance time of 600 millimeters. And if we go to just to relate the irradiance intensity with the dose, that's really just a function of time. So, for example, if you have a radiance of 1,500 microwatts per centimetre squared for 1 second, you'll get a dose of 1,500 microjoules per centimetre squared, and that will give you a good reduction in pathogens like COVID. And in this example, for example, you've got air moving at 2.5 seconds, and you've got 600 millimetre irradiance zone. You basically need 6,500 microwatts to achieve that sort of dose to try to kill some of the COVID moving through your air handler. And this is a specification that came out recently or late last year, which actually aimed for 2,000 microwatts per second, so microjoules, if you like, per centimetre squared dosage across coil, and this looked like to us as an air disinfection specification. But again, the cost implications of this are really significant. I'll just go back to that slide where we've got compared to our recommended dose of what would be 250 microwatts. This is using $657 per annum electricity versus $167 per electricity per annum to achieve that air disinfection rate. So it's quite a significant jump in what are 2 very small air handlers, significant jump in electricity costs in what are 2 fairly small air handlers. And one of the things to recognise, and this is quite important, is that there's a cooling effect on lamps sitting in front of the coil. So if you've got a chiller or air handler operating at 13 degrees centigrade, 13 degrees centigrade, maybe at 2 meters a second, you will get a wind chill of approximately 50% for an unprotected bulb, a wind chill factor. So that means that that UV lamp is putting out 50% of what it would at a warmer temperature, sitting in front of the coil. Now, one of the things we do when we install in front of coil is put the parabolic reflector in behind it, which does limit the wind chill effect. It also limits damage to the air handling unit. But in terms of trying to disinfect in front of coil, trying to achieve air disinfection in front of coil, you're going to be using a lot of electricity, and I'll have a look more at those numbers in a second. When Sanovox products are trying to achieve disinfection, we actually install the lamps parallel with the airflow, and here's a diagram of two biowalls installed in the supply air duct, and which means you have much better contact time with the air moving through, and it's much more energy effective in terms of kill per kilowatt hour of electricity used. The photo below is an example of one of those installations, duct installations. I'll just play a video of a Sanovox installation. That gives you an idea of what that looks like, the biowall, and it can be retrofitted to just about any duct, whether it's supply air or return air. And with our software, we can also calculate the relative costs of trying to inactivate or achieve disinfection. In this example, we're trying to achieve a 90% single pass disinfection of SARS-CoV-2. And one's a perpendicular installation versus a parallel installation. So the second installation is a biowall installation. And just having a look at the numbers here, the electricity costs of achieving the same rate of disinfection, one in duct, one in front of coil, is 2.5 times higher. So that's just locked in. And also the ongoing capital cost is actually higher because you need to put a number of lamps in front of the coil. So we do not recommend air cleaning in front of coil. We recommend putting low power lamps in front of coil to kill static organisms growing on the coil face. That is not the spot where you want to try to achieve air disinfection. Why you might want to do higher UV intensities is just possibly because the manufacturer wishes to sell more lamps. And just doing some basic calculations on lamp life using DA15 criteria, over a 6-year period, these sort of unshielded installations are going to use 4 times more the number of lamps compared to the Sanovox installation. Sanovox lamps guaranteed for a 17,000 hour or 2-year period of time running full time. And at the end of 2 years, they've only declined 25% in output power, whereas the competition has typically a 50% decline over a 1-year period. So buyer beware when you're looking at lamp installations. The quality of installations vary, and here's a photograph of a Queensland hospital where the photo on the left is an induct attempt at air disinfection. So it's just sitting there perpendicular to the airflow, single lamp there. And the other one's a coil installation where they've used the lamp as a structural member. The photo on the right is a photograph of unshielded lamp on coil, and you can see the filters on the right-hand side. These lamps are unshielded, and so they've effective and they've been installed upstream of the coil, so upstream of the airflow and in front of the filters. And these filters have been destroyed and are probably not even rating as a coarse filter anymore. They're F7s, so high-end filters, or F8s. There's also damage inside the air handling units with unshielded lamps, and that certainly is a consideration for the powder coating, as well as any plastic products such as this unshielded power supply to the fan here. So some damage happening there. There's also considerations regarding different products. This is my buyer beware part 3. At the recent IHEA conference in Adelaide, one of the suppliers marketing a new product of 405 nanometer LED lights as part of a surgical installation with HEPA filters up here. And the 405 nanometer is supposed to disinfect the room, and it's much safer for any occupants in the room while the lights are on. By our calculations, looking at the active power of 405, it's 30,000 times less effective killing pathogens compared to the equivalent dose of 254, and you need to shine that light for a very, very long time to contaminate. Sunlight is more effective. The other products on the market, a very, very interesting product, which is it's not an LED, but it's like a LED, and it puts out UV at 222 nanometers. It's called Krypton chlorine excimer lamps. They're much more germicidally effective than 405, but less so than 254. With only 8 times more exposure required. But these have been marketed as lamps that can be installed in occupied areas, and a recent study's shown actually that there's a real risk of ozone generation and formation of secondary aerosols in these occupied areas. So the jury's still out on the efficacy and safety of these lamps, but you can go and buy them online now. This is the germicidal curve effectiveness, where you can see the 254 is near the top of the curve in terms of capacity to kill pathogens. 222 is sitting down here, and 405 is actually off the graph. I think sunlight's more effective than 405. Anyway, these other lighting products do actually confuse the marketplace, and it's hard to, as a consumer, to distinguish between what works and what doesn't. The other thing, and this goes to the fourth category of fourth box of the slide I showed earlier of fumigation products. So this is from a recent ERA trade night product being sold in Australia for the domestic market. And this product releases hydrogen peroxide into the breathing zone of occupied spaces. Hydrogen peroxides are very effective as an oxidizer, and it will react with pathogens in air. And we use hydrogen peroxide. Apira use hydrogen peroxide when we're using it as a vaporized hydrogen peroxide to sterilise clean rooms and pharmaceutical areas. But we generally move people out of those areas. This is designed to actually provide low doses of hydrogen peroxide to occupied areas, below which occupants won't notice the concentration now. And to be fair to hydrogen peroxide, its exposure limit is 10 times lower than the equivalent exposure limit to ozone. And ozone really, the recommendation now coming out of ASHRAE is to have zero ozone in the breathing zone of people. We don't want to be dosing ozone into places. So anyway, there's a new products coming out, and these may or may not be really effective, and they may or may not be, healthy for occupants. The other new products on the market in a very similar category as a previous one, it produces hydroxyl radicals, free radicals, and again, sunlight actually produces hydroxyls when it hits water molecules in air, and you do have a very short half-life for these. They decompose very radically, and in fact, UVC at 254 also generates hydroxyl radicals, but again, they don't last very long in terms of an occupied area, in terms of breathing zone with less than a second half-life. And it's being used more and more in the restoration industry, replacing ozone. So this particular product aims for a background concentration of about 20 or 30 parts per billion in occupied areas, and it says that that's safe for the occupants, and it mimics outdoor mode of action. Now, I did a quick Google research on saying, okay, who's done the study showing that this is fine to do and safe, and the most recent publication I could find was a 2015 publication saying it's something that needs to be studied, and it's a research topic of great concern. So let's be cautious, I suppose, in terms of adoption of these new technologies. But anyway, watch it with interest. Look, when you go ahead and buy any of these products, I think it's incumbent on the importer to make sure that it's registered with a regulatory compliance mark, and any of the suppliers in Australia should have these. So our IL Core Cleans are registered on the Regulatory Authorities Council website. It's actually the National Equipment Registration System. And just to wrap this up, the key points of difference with Sanovox, these are engineered solutions. We're trying to achieve energy efficiency, and we're trying to achieve lowest total cost of ownership with wiping out a pathogen. So there's a lot of new product on the market. Sanovox has been selling their products, or selling their products since the mid-90s, and they've got a good pedigree and a great track record. So no surprises for our customers. There's some references, and there's a little bit more about Apira. So thank you for listening in, and we hope you enjoyed that presentation.